if I was a founder right now, I would absolutely adopt open source. It forces me though to look at the engineering complexion of my org, right, and think like I'm going to need people doing LLM ops and things like data fine tuning and how to build RAG and things. And APIs, there's plenty of APIs that allow you to do this, but like ultimately you want control. Like your moat is your data, your moat is your interaction with users.
Hi everyone, welcome to Training Data. Today we're excited to welcome Joe Spisak, Director of PM for Generative AI at Meta, where he leads Llama and third-party ecosystem efforts. Joe spent the last decade in AI, leading product at PyTorch and working on initiatives that span protein folding and AI math, many of which have spun out from Meta into their own startups. We're speaking to Joe just 2 days after the Llama 3.1 405B launch, and we're excited to get his view on questions like, where is the open source ecosystem headed? Will models commoditize even at the frontier? Is model development becoming more like software development? And what's next in agents and reasoning, small models, data, and more? Joe, thank you so much for being here today. We're so excited to have you just 2 days after the Llama 3.1 405B launch. It's an incredible gift to the ecosystem. We'd love to learn a little bit more about what specific capabilities you think the 405B is particularly unique at, especially in comparison to the other state-of-the-art models.
Oh, thanks so much for having me. This is so much fun. I haven't done a podcast like this since something pre-COVID. So it's like fun to be in the same room and just like, chatting about this cool stuff. We're like beyond excited at Meta. This was something that I think a lot of us have been working on for such a long time, months and months and months. And, we kind of put out that nice little like appetizer, I'll call it, in April of like Llama 3. And like, I was actually like, are people really going to like be that excited about these models? And like the response was like through the roof. Like, oh my God, like everyone's excited, but they really don't know what's really coming. And so like, had to hold that back for a while and kind of keep it to ourselves and then kind of build up for this launch. And the 405B is a monster. It's a great model. And I think the biggest thing we've learned about the 405B is it's like a massive teacher for other models. And we kind of had that plan all along, because when you have a big model, you can use it for like improving small models or just like, distillation. And that's how the 8 and 70s became the great models that they are. I mean, in terms of like capabilities, like, we listen to the community. We listen obviously to our own product teams, right? Because we got to build products for Meta. And I mean, long context was like one of the biggest things people wanted. And we have, much longer context internally even than what we released. But we saw like just the use cases like start to build up. Multilingual, I mean, we're a global company. So we released more languages, many, many more to come, because obviously like Meta has billions of people on their platform and hundreds of countries. And so I think that was like, to me, those are like table stakes things, but they're like really done well on the models. Like I think we spent a lot of time in post-training on our different languages and improving them and safety. Just they're really, really high quality. So we don't just like pre-train on like a ton of data and say, look at us, we're multilingual. We actually did a lot of work in our SFT phase and supervised fine-tuning and a lot of safety work. I think one of the coolest things that I'm excited about, there's a couple of things I'm excited about, but one is tool use. Like I think, the models, oh my God, zero-shot tool use. This is going to be crazy for the community. We show a few examples, like we can show like calling Wolfram, or we can, Brave search or Google search, and it works really great. But zero-shot tool use is going to be a game changer. The ability to kind of call a code interpreter and actually like run code, or kind of build your own kind of plug-in for things like RAG and other things, like, and have that really be state of the art. I think is going to be a really big game changer. And I think just the fact that we released the 405 itself and we changed our license so you can actually use our data, like that was a big deal. Like that was a big discussion. We had many meetings with Mark on that, and we and ultimately like landing on a place where this was like this pain point for the community for so long. They're like, these closed models, like I can't use the outputs, or maybe I can use them, but maybe I'm using them slightly unscrupulously or whatever. Like we actually are encouraging people to do it.
I'm sure that was a tough decision to make. Walk us through the things that you had to consider in actually making that leap to open up licensing in that way.
Yeah, licensing
super permissible.
Oh, licensing is like a huge topic in itself. Obviously, like we could probably spend the whole podcast talking about it. I don't want to, but we could. I think we wanted, number one, just to unlock new things. Like I think we wanted to have the 405 and our Llama 3.1 models differentiate, give people new capabilities. Like we just looked at like what people were really like excited about in the community, not only in kind of enterprise and products, but also in the research community, because we obviously have a research team, and we work with academia, and we talk to folks. I mean, Percy Lang at Stanford texts me all the time saying, when are you going to release it? When are you going to release it? Can I use it? Can I use it? And Percy, like, stay patient. But I think we heard them, and we knew kind of what they wanted, and I think ultimately we wanted Llama everywhere. We wanted just adoption, maximal adoption, really the world using it and building on it. And I think Mark even used in his letter he put out the new standard or standardized. So I think like to do that, you kind of have to enable stuff like that, right? You kind of have to unblock all these different use cases and really look at what the community wants to do and make sure that you don't have these kind of artificial barriers. And that's what the discussion really was. And so actually even beyond that, we started working with, partners like NVIDIA and AWS, and they started building distillation recipes and even synthetic data generation services, which is pretty cool. I mean, you can start to use those and actually create specialized models from it. And the data we know how good the data is because we used it in our smaller models. It's really good and it improves our models significantly. So
I want to pull on the open source side a little bit more.
Sure.
And I've read Zuck's manifesto. It was great. But I'm trying to wrap my head around like what's in it for Meta. This is a massive investment to open source. In some ways, you're leaving a lot of money on the table because you now have a state-of-the-art model that you're offering to everybody for free. And so I guess, is this an offensive move? Is this a defensive move? Like, what's in it for Meta?
I mean, well, first of all, our business model doesn't depend on this model to make us money directly. So we're not selling a cloud service. We've never been a cloud company. We've always worked, I would say, with a partner ecosystem all the way back to like the 5 years I was like helping to lead PyTorch, and the ecosystem, the community we built around that. Like we never built a service. We probably could have in some way, but it would have been weird. We saw basically, going back to PyTorch, we kind of saw it as this kind of lingua franca kind of bridge, to this like area of high entropy. This is kind of a weird way to say it, but like there's all this innovation happening. How do we kind of build a bridge to it and actually be able to harness all that innovation? And the way to do that is to be open, and is to kind of get the world building on your stuff. And I think that ethos is kind of carried over into Llama. And, if you look at PyTorch, like that was a huge way for us to kind of pull in, at the time when we really started working on PyTorch in earnest, computer vision and like CNNs and all that, right? If you remember that, old times now. But we actually would see these architectures come like constantly. The people and they'd write code and they'd publish it in PyTorch. And we take it internally, we evaluate it. People would open source models and put them out on model zoos, and we'd evaluate them, and we'd see just how quickly the community was improving things, and we'd actually leverage that, especially for like integrity applications where we release like hateful memes and some of these other data sets. We just saw the improvements like week over week, month over month, and it was built on something that is like we were using internally. So it was very easy for us to just take it inside. So I think like Llama is definitely similar in that regard, where, when academia and when companies start to red team these models or, try and jailbreak them, we want people to do that to our models. And so we can improve. And I think that's a big reason. And it's like, be careful what you wish for, right? Of course. But like, it's the same with Linux, right? The Linux is open source and the kernel is open source, and people will, it's much more secure when things are transparent and bugs can be pushed faster. And so that helps us a lot. I think it's, there's also the angle of, we don't want this to turn into kind of a completely closed environment. Like I think just like today, if you look at like Linux and Windows, and like in my opinion, there's there's room for both, right? There's room for closed, there's room for open, and people use depending on what they need and the applications. I think that there's going to be a world of of open models, and I think there's going to be a world of closed models, and I think that's totally fine.
What was the primary argument against open sourcing? Was there one?
I mean, there was definitely like competitive concerns we talked through. Do you want to give your technology, put it out there and that, and I think we're like less concerned about that because we're moving really fast.
Yeah. Like
if you look back, I mean, I've been back. I've been at Meta like close to 6 or 7 years now, and like in the last year or so, we've done. We had a Connect launch. We released Purple Llama last December. We released Llama 3, 3.1. Before that, we released Llama 2 in July. Llama 1 was like in February. So like just if you think about the pace,
incredible.
The pace of innovation that's like coming out of our team and our company is like just at a crazy pace right now. So I'm not too worried about it. I don't think we're that worried about it.
I'd love to kind of move into your personal views on the broader ecosystem. I think a lot of the questions that people have center around what happens to the value of all these models, especially as Meta open sources more of them at the state-of-the-art level. With Llama 3.1, with OpenAI launching GPT-4o Mini, what is your view on, do models commoditize even at the state-of-the-art frontier?
Oh, this is a great question. I mean, I think if you look at just in the last 2 weeks, I mean, 4o Mini is a really, really good model. Input per million tokens is something like 15 cents, 60 cents out. So it's incredibly like cheap to run, but it's also an excellent model. Like it's just like they've done an incredible job in distilling and getting to something that's like really, really performant yet really, really cheap. So I think like, Sam is definitely pushing on that. And then if you look at what we've done in like the last week and pushing out, I would say like pretty compelling state-of-the-art models across the spectrum. I do think like it's rapidly getting to a place where, the model is going to be kind of a commodity. I mean, I think there's this frontier of like data, where, we can certainly gather data from the internet, we can license data, but at some point there is kind of like some frontier of limitations I think that we're all going to have. And this goes back to our conversation this week on, kind of the bitter lesson of data and scale and, compute. Is that enough? It's probably not quite enough, but it's like compute and data becomes kind of, if you have enough of both, you can kind of get a first order approximation of the state of the art without anything else is kind of what we've seen. So I do think the models are commoditizing. I think the value is elsewhere. And I look at Meta and I look at our products and I look at like what we're building, like that's honestly where the value is for us. It's Meta AI, it's our agent. It's all of the technology that we're going to put into Instagram and WhatsApp and all of our end products where we actually are going to monetize, where we're actually going to, to add real value. The model itself, I think definitely we'll keep innovating, new modalities, new languages, new capabilities. That's what research is, right? It's pushing the frontier in emerging capabilities, and then we can leverage those in products. But the models are definitely like pushing in that direction.
Yeah. If that's the case, and all these existing companies that have massive distribution and wonderful applications that are already out in the wild can just adopt these state-of-the-art models, what advice would you give to the whole wave of new startups that are trying to make it out there, either building their own models, using other state-of-the-art models, and then trying to build applications on top?
Yeah, I mean, there's definitely like some model companies or companies that are building, they're pre-training foundation models, and it's expensive. It's like, I think we're, I can't say how much Llama 3 cost, but it was very expensive. And, Llama 4 is going to be even more expensive. And so to me, given kind of the state of play and things, it doesn't make that much sense if I was a startup to try and go and do a pre-training. Like I think the Llama models are absolutely incredible as foundations to build on. And so I do think like there is, if I was a founder right now, I would absolutely adopt open source. It forces me though to look at the engineering complexion of my org, right, and think like I'm going to need people doing LLM ops and and things like data fine tuning and how to build RAG and things. And APIs, there's plenty of APIs that allow you to do this, but like ultimately you want control. Like your moat is your data, your moat is your interaction with users. And you're also, you may want to deploy these things onto a device at some point and have kind of a mixed interaction or something. You might want to have like simpler queries like running on your device and have like, very low latency interactions with your users. You might want to split, and have like a more cloud-based approach for more complex queries, more complex interactions. And I think like the open source approach gives you that flexibility. It gives you the ability to modify the models directly. You own the weights. You can run the weights. You can distill them yourself. There's going to be distillation services that allow you to take your weights, distill them down to something smaller. I think that's pretty awesome. We're like just now seeing the beginnings of that. So I think like in my mind, like control matters a lot, and ownership of the weights. There are a lot of like API services where you'll do fine tuning your model. So you're bringing your own data, you're fine tuning, and they use something called low rank adaptation or LoRa. And unfortunately, you don't actually have access to those lower weights at the end of it. You're kind of like forced to use their inference. So you're like, let's see, I'm kind of like held hostage here. Like I've given my data. I don't have access to like the actual IP that was generated from that data. And now I'm forced to use their inference service. Like that's not a good deal. So I think the open source kind of like brings inherent freedom that I think that approach doesn't. So.
What do you think of Mistral Large was announced, I think, maybe a day after Llama 3.1. What do you think of them? And I guess more broadly for everybody at the frontier, is everyone kind of pursuing the same recipes, the same techniques, the same kind of compute scale data, et cetera? And so like, everyone's kind of going to be roughly similar at the frontier, or do you think you guys are doing something very different?
So first of all, on Mistral, amazing team. It was one of my old teams in FAIR. They were working on through improving and AI and mathematics. So Guillaume and Tim and the team and Marianne, they're incredible.
Joe was just talking about fun banter last night.
So this was like one of the scrappiest teams that I've ever worked with. I mean, the team, I don't think ever slept. So it was like basically by day they're doing like pushing.
Probably even less now.
Probably even less now. I mean, they would push the state of the art in like AI and they're improving and, during the day, and we published some work on that. I think a couple of years ago now, geez. But by night, they were basically like scrappily like grabbing compute to train Llama 1. And so they were, we were building large language models several years ago in FAIR. And, that team basically just like they were just really ambitious and they were kind of working by night. And that's really where Llama 1 came from. So the team is great. I think they're doing really good work. I think they're definitely challenged in that they're trying to also like open source models, but also make money. And, like models like 4.0 mini are not helping them. Cause and this is, I think, why they changed their license, for example, to like, to having a research only license, which kind of makes sense. Because they were, open sourcing models and they immediately like their own ecosystem is like competing with them in a lot of ways. Because they'll release a model, they'll host it, like use this model, but then they have, Together and Fireworks and Lepton and all these companies that, provide like sometimes a lower cost, per million token, like offering. So it's really tough business right now. In terms of like large too, I think it's a really good model. We just on paper, I haven't evaluated it. We haven't looked at it internally yet. I think, if you look at like artificial analysis, I think they added up in kind of like it was under, I think, like the 70B model, in terms of like quality, but that's like a blended, they blend a bunch of benchmarks to make that distinction. But on paper, it looks really good. We're going to evaluate it. I think, for me anyway, like the more the merrier, like the more models are out there, the more companies are doing this, the better. It's not like we're not going to be the only one. And I think that's good that we're not the only one. And I think like more generally, like the Gen AI space, like you wake up every single day and you kind of expect something like this, right? You expect a model to be released or something groundbreaking to happen. And that's kind of like the fun of being in it. So
Totally. Do you think everyone at the frontier is comparable though? Like, are you all pursuing comparable strategies?
Yeah, this is actually a good question because, if you read the Llama 3 paper, which was, I think, 96 pages, you ended up at, right? lots of citations, obviously.
Lots of sharing.
Lots of like, contributors and core contributors and that. So like it was a detailed paper. And Lawrence and Angela on the team spearheaded writing that. And I think that was like one of the hardest things. Like developing the model was like relatively easy compared to writing the paper. It was a lot of work putting that paper together. I think if you look at Llama 3, there was a lot of, I would say, innovation that happened, but also we didn't, I would say, take on like a lot of research risk either.
Yeah.
So I would say like the primary things we really did with Llama, with the 405B especially, was really pushing scale. I mean, it was still, we use group query attention, for example. So, GQA, and that improves inference time and, kind of helps solve the kind of quadratic attention computational challenge. We trained on, over 15 trillion tokens. We in post-training, we used synthetic data, which improved the models, the smaller models quite a bit. We trained on over 16,000 GPUs on our training runs, which is something we hadn't done before. It's really, really hard to do that because GPUs fail, and
it's off the table.
Yeah, I mean, everyone's like, oh, I'm just going to train on 100,000 GPUs. Like, good luck, right? You better have a really, really great infra team, a really great MLSys team. You better be like ready to innovate at that level because it's just non-trivial. Everyone says it's easy or says you can do it. It's non-trivial. So I think like I almost look at Llama 3 as very similar to like the GPT-3 paper. So if you ever talk to like Tom, he was a lead author, Tom Brown, now at Anthropic. And there's a reason why Tom was the first author on that paper, is because like a lot of the innovation was really scale. It was really like, how do I take something that's, like an architecture and like push it as hard as we can push it. And that involves like a lot at like the MLSys kind of layer and infra layer, and like, how do I scale the algorithm? And so I think that was really like the mentality we had with like Llama 3.3 and Llama 3.1. And I mean, internally, obviously, we have a great research team. We have FAIR, we have research in our org, and we're looking at lots of different architectures and MOE and other things. And so, so I think we, who knows what Llama 4 will be. We got a lot of candidate architectures, and we're looking at it. But it's kind of a trade-off. It's a trade-off between how much risk you take on as like for research, and potentially how much reward or the ceiling of the potential improvements, versus just taking something that's relatively known and like pushing scale and getting that to improve even more. So ultimately, this becomes a trade-off.
I think this is such an interesting point. I actually also think it makes Llama and Meta quite unique in the strategy it's taking. The words that I like you used yesterday is model development becoming more like software development.
Yeah.
I'm curious to hear if you think, unlike what many of the other labs have been doing on pushing more of the research, you guys have been focused on just executing on strategies that work. Do you see that representative of the continuous strategy, you think, as you extend Llama out 4, 5, 6, 7, 8? And then also, how do you think the other research labs and maybe some of the other startups in the ecosystem will react? Will they kind of switch and veer a little bit more to the strategy that you've been taking?
I mean, it's a really great question. We don't have all the answers for sure, I think, but there's definitely like somewhere in the middle right now is kind of where I see things landing, where, we'll continue to push, and on execution, we'll continue to push models out. We'll continue, because we want our products to iteratively improve as well. So we want Meta AI, improving constantly. And so there's definitely like a software engineering, analog here that's happening, where, you can imagine something like a Llama train, and, new features and new capabilities get on that train, and we have a model release. It's much easier when you start to componentize the capabilities too. Like we're doing that with safety right now, and you saw in the release, we released Prompt Guard and a new Llama Guard, and you can iterate on those components externally, and it's great. Obviously, the core model is much more difficult. I do think we'll start to include or start to kind of push on the research side, because as well, because I think the architecture like is going to evolve. I mean, you've seen like what AI2, for example, has done with their Jamba and their Mamba, and everyone kind of thinks Mamba is like a new architecture that could have promise. I think what's interesting though is like to truly understand like the capabilities of the architecture, you kind of have to push the scale. Yeah. And I think that's what's missing right now in the ecosystem is, if you look at academia, and academia is like a lot of absolutely brilliant people there, but they don't have a lot of access to compute. And that's a problem because they have these great ideas, but they have no way to truly execute them at the level that's needed to really understand, will this actually scale? Because like the Llama paper and model was really interesting and the benchmarks look great, but they didn't scale it beyond, I think, like under 10 billion parameters. So you're like, okay, what happens when, we train this in the hundreds? Like, do you still see those improvements or not? And no one really, at least outside of these labs, knows the answer yet. So I think that's like one challenge. So I think like, to me, we're going to get into this hybrid space of, we are going to push definitely on architecture. We have a very, very smart and well-accomplished research team. But we also are going to be like, we are going to be executing. And I think that's when we start to get like a recipe. We're going to push it to the limits. And, we are going to start, we're going to continue to release more models on it. But in parallel to that, we have to push on architecture.
Yeah.
And I think it just makes sense because the next breakthrough, at some point you're going to reach a kind of a theoretical limit. And you need to evolve the architecture, right? So I see kind of a little bit of an in-between. And obviously we're really good at execution. I think we're pretty good at execution. But we're also good in research. And we just need to marry those two so it makes sense. Because like research and products are very different, right? Like one should be pretty deterministic, the product side. And one is inherently non-deterministic, right? It's like, is this going to work? I don't know. It's a really big bet. If it fails, it's research. Like, it should have a non-zero chance of completely blowing up in our face. We just need to go in another direction. But that's what research is. So
I'm curious about one branch of where a lot of, I think, model research is happening right now, agentic reasoning. And I think you all have announced really great results in reasoning. I'm curious, maybe at a very basic level, how do you define reasoning? And then are you all seeing reasoning fall out of kind of scale during pre-training? Is it post-training? And is there a lot of work left to do on the reasoning side?
Yeah, reasoning is a bit of a loaded area. I mean, you could argue it's things like multi-step, like and I think unfortunately the best examples we have are like the kind of like the sort of semi-gimmicky, Bob is driving the bus and like he picks like those kind of like things, right? And if you troll local llama, you'll see a billion of those, right? But those actually force the model to take multiple steps to respond to you and think through and logically kind of respond. I think coding is actually really like, when you look at like pre-training, so I like to answer your question directly, like reasoning improvements come in both post-training and pre-training. So what we've learned, which is now like everyone's like, oh, of course this is the case, but definitely like the last year or so, everyone's kind of learned that, code, having a lot of code in your kind of pre-training corpus really improves reasoning. But that's when you think about it, like, of course, duh. It's step by step. It's very logical. It's, code is just logical by nature and kind of step by step. And like, if you incorporate a lot of that in your pre-training, your model will like reason better. And then we of course like look at examples in post-training and like super SFT to improve as well. So we look at the pre-trained model. And it kind of depends on how you balance things as well. Like you can balance like how well your model reasons with how well it responds to different languages. Like ultimately in post-training, like everything's a little bit of a trade-off. Like you can super optimize things for coding if you want to, and we did that with Code Llama. It was really great, but of course the model will suffer like in other areas. And so ultimately it becomes what kind of like Pareto frontier of like capabilities we want to like bring out if it's a general model. And I think like, ultimately it's a trade-off. So anyone can kind of pick a benchmark or some capability and say, I'm going to super optimize for it and say, by the way, I'm better than GPT-4. Well, great. Anyone can do that. Like, but is your model as generally capable as GPT-4 or Llama 3.1 or whatever? Like that, I think is a different story. So
what do you think are the future levers to unlock reasoning for anyone going forward?
I mean, the obvious answer is data. The more data, the more code and supervised data that you can get, I think is a natural answer. I think we need to find applications as well for how we like define it, and that would help us. Like once you've kind of start finding like those kind of killer applications, then you kind of know where to kind of focus in terms of your gated. exactly what you're solving for. Like, and this goes back to like evals and like what is your eval, because we're starting to saturate evals. And so we tend to, as a community, like we define a benchmark and a metric, and we just like optimize the hell out of it. And it's great, but then you actually look at the model in an actual environment, and you're like, oh, well, that model has a better MMOU score. Great, but like, how does it actually respond? Well, it doesn't respond as well, but it has a better MMOU score. And so I think we need better evals and better benchmarks that allow us to, I would say like find clearer line of sight to actual interactions. And I think like, the live, what is it called? The Abacus benchmark, the live bench, I think it's called. I can't remember the name of it. Is pretty good. I was looking at that. And of course, like LMSys and Chef out Arena, like these are more natural, even though, it's still not perfect, but it's like moving in the right direction of things that are like more human like interactions versus like a static data set or static prompt set that is not that helpful. So I think like once we start to find these other like what reasoning use cases make sense, we're going to start to generate more data, and you're going to start to improve the model there. And hopefully that kind of has, again, line of sight to a benchmark or an eval that actually feels like it improves the end product. And a lot of this actually depends on the end product, of course. Like, what is my application?
Yeah.
So.
Yeah. Out of curiosity, I think within large research labs, coding and math have always been two primary categories in trying to unlock reasoning.
Yeah.
In the startup ecosystem now, we're seeing more folks who really want to go it from the math angle.
Yep.
Do you have a perspective on whether or not that has led to interesting unlocks?
I mean, the answer is yeah. I mean, I think if you look at our data, or like at least our models, we've like coding and math have been, I would say, the primary levers. I mean, it's yeah. I mean, I think that's like having more obviously is better, because obviously math is also very logical and very like stepwise. So obviously you can see the pattern here. The more data you have, like that kind of follows that sort of pattern, the more your model is going to be able to reason. And you can see that in how actually models respond. Like if they start and you ask them to like respond and like step me through your thinking process, right? And it'll actually do that. And some models do better than others. So anything like that. I think scientific papers, like also there's like, we had we had some like projects out of FAIR that like trained on, like archive papers, and you can see like not only is like code and math, like pure mathematics, but also like scientific paper, which is like scientists are very logical in how they write things and how they stepwise and how they like create images of their like charts and stuff. And like that also, I think we've seen like just general scientific information like helps as well. So Galactica was our project. Yeah. So Robin Ross from the Papers of the Code team led that. Still, in my opinion, like one of the coolest projects ever. It got a lot of like bad press, but wow, they were ahead of their time, in my opinion. So
I'd love to talk a little bit about small models. Given the scale of capital and the compute that many startups have, the 8B and 70B models are an incredible gift to the ecosystem. And it's funny that you called them appetizers at the start, because I think they're super powerful for that set. But they're also really powerful for a number of different applications where you want smaller models. And so I'm curious to hear, what do you hope to see developers use the 8B and 70B models for, given that they are best in class for their size of model?
So it's interesting, though, when we released, April, Llama 3, we released an 8 and a 70, the appetizers, as we call them. The 8B was actually better than the Llama 2 70B by leaps. So we were, I had to look at the chart, and I was like, is this right?
Yeah.
Like, is that really the case? And we're like, yeah, it really is. It was that much better.
What's the intuition for how that happens?
I mean, it was more data. We had 7x more data. Obviously, like we put a bunch more compute at it as well. So, going back to like compute and data, being, we're pushing on those. So I think like we just, we saw like just like it's almost like every generation, which is again the generations are accelerating. You start to see the benchmarks for like a large model basically get like pushed down into the smaller like size regime. And so, 70 becomes an 8. And, like internally we have models where the 8 is, like on a much even smaller than 8. Actually, we're starting to see like really nice benchmarks on even smaller models. So you continue to see like, and that, that the models improve at smaller scale. And that I think is just, we're pushing the architecture, we're pushing scale, and we're starting, we haven't quite saturated it yet. And I think that's really interesting. So, for me, one of the biggest reasons that I think like a small architecture is useful is obviously on device. Everyone loves to talk about on device, and Apple's, talking about that, and Google has, Gemma models and Gemini running in Android devices. So I think like on device makes sense. I think safety is kind of interesting because, one of the things we have our own internal versions of Llama Guard, which we used that are orchestrated for our applications internally at the company and at Meta. And, today they're built on an 8B model, which is kind of expensive to run if you think about a safety model that's kind of like this secondary model. And so I do think, internally we've been experimenting with much smaller models in that regard. And it creates efficiency, it lowers latency. Because really, those models are really just classifiers. They're not really autoregressive like chat-like interfaces. They really just classify like the input a prompt of, does that violate, this whatever category in the taxonomy. In the output, the model when it generates, does it violate that kind of stuff? So you can actually push those even further. Yeah. I think that there's also like really interesting cases though for like on device, where you almost have like when you think about privacy and you think about data, you want to have like your data stay on device. You can think about, like a RAG like architecture on device. Yeah. So you have data, even your chat history that's like on say WhatsApp or other things. You can imagine like that model having access to data, aggregating it, and then running some type of, almost like a mini vector database, right? Where we're using RAG and doing your kind of fuzzy search or fuzzy matching and with your like small model, and that becomes its kind of own system in itself. And you can basically do things like local summarization. Like, I don't know, like I get so many text messages like, hey, like summarize my last 15 messages, please. Cause like I've been in meetings and I haven't looked at my phone. And that's like super useful. And then I don't have to send, data up to the cloud or anywhere else. So there's like those kind of use cases, I think, that where small models actually are going to be really compelling. Yeah. And then for like super complex queries and things, obviously like you have a big model in the cloud that can always service those. But for like many things, I think like on device or even, in the edge and on-prem, these small models actually can do pretty good.
You talked about kind of scaling up compute and data as, the two fundamental vectors to improve performance. I guess there's been a lot of chatter about how we are going to hit a wall, or maybe we're not going to hit a wall on data and maybe synthetic data is the answer, et cetera. I'm curious your perspective on that. Like, is there an impending wall that we're going to hit most likely of, cheap, accessible data? What do you think? How do we scale beyond that?
I mean, I think we've shown with this release that synthetic data does help a lot. I mean, I think we've, in pre-training, we trained on 15 trillion tokens or give or take. And in post-training, we generated a ton of, millions of annotated synthetic data. A lot of it generated by the 405B. We obviously paid, for annotations as well. I do think synthetic data is like a potential path forward. I think it's going to, like we know now, and the kind of proof is in the models, right? It's like great to talk about it in that. I do think, data is going to be a challenge at some point for us. And this is why I think, companies are licensing a lot of data these days to get access. I mean, OpenAI is licensing data. We're licensing certainly data. I think having access to services that generate data to improve models is important. So I think that inherently is an advantage for a lot of companies. I mean, Google has YouTube, right? They can, I'm sure, is of value to them. So, which kind of implies that, bigger companies have an advantage, which is not something that's anything new, right? We've been talking about this for a long time. Totally. In terms of a data wall, I don't know. I mean, I think we're not there yet. I would say like, let's schedule this for like a year out and let's see where we are next year. I'll save my calendar, for 1 year exactly from now and, Meta AI. Let's talk in a year and see where we are. But we haven't hit it yet. And we're still scaling and we're still, we're still gathering a lot of data and we're generating data, and our models are still continuing to improve. So, yeah.
Let's close it out with some rapid fire questions.
Sure, sounds great.
In what year do you think we'll surpass the 50% threshold on SweBench?
Good question. If I've learned anything, it'll be faster than whatever answer I give you. Because I think any benchmark will, as soon as we zero in on it, people are going to go and figure it out. So I don't have an answer. It'll be fast, I'm sure.
One of the questions we have been asking people is, in what year will an open source model surpass the other companies on the the other models on the frontier? And we have to take out that question now, thanks to you all. I
mean, it's true. We're almost there. I mean, I think 405B is incredible. It's definitely in that class.
Yeah, absolutely.
Which is incredible.
Will Meta always open source Llama?
I mean, I think Mark's pretty committed. You saw his letter.
Awesome.
I mean, we've open sourced, for years and years now, back to PyTorch, to Fair, to Llama models. This isn't something that's a flash in the pan for the company. Yeah. The company's been committed to open source for a long time. So I wouldn't never say never, but the company and Mark are really committed.
Amazing, Joe. Thank you so much for being here today,
and
also for all the work that you're giving to the entire ecosystem. I think the entire AI community is very much grateful for all the work that you've done with pushing out Llama and the advancements to come.
It's a huge team. Check out the paper. Look at all the acknowledgments.
I think we spent all of yesterday reading it.
We need the Star Wars scrolling text of all the contributors, because it was an incredibly big team.
I was thinking about that same thing.
So my hats off to the team. This was a total. This absolutely took a village to get Llama out there, and I'm so proud and excited to represent the team here. So thank you.
Thank you.